So, Miss Palacios making mini cakes. You might actually remember this from last year.
I do.
We talked about mini cakes and confetti
Oh, yeah, you got the
candy.
video, and you put mini cakes on it.
Oh.
Our mini cakes
Alright. So each one takes 1/5 of a teaspoon. She has 15 1/8 teaspoons total. How many can she decorate? If you're not sure what to do with that, because these numbers are kind of terrible fractions and mixed numbers, if we just ignore those for a second, put in some whole numbers that we can work with. So what if we said it took 2 teaspoons each and we had a total of, I don't know, 20 teaspoons? How many could she make?
11.
Why would it be 10? Because it's 20 divided by 2 is 10. So what do you think we're going to have to do with 15 1/8 and 1/5? We're going to have to divide them.
How do we know to divide it?
Because you just said if it was 2 teaspoons each and you had 20 teaspoons, that you could make 10 because you divided. 20 divided by 2 is 10. So all we're doing with these two numbers is dividing them.
But how are you going to divide it with their fraction?
That's what we're going to get to next. All right, 15 1/8 divided by 1/5. We then turn them into decimals.
20.
I would like it very much if we knew these already, but sadly we probably don't. So we use Tebow to get 1/8.
We don't have to move the decimal.
Please don't wait for someone to tell you the answer. So any word to say should get 0.125, which means 15 1/8 is 15.125 divided by 1/5. I would really hope we knew what 1/5 was as a decimal. That's just 0.2, 0.20.
Oh, it is?
Yes.
2 times.
Okay, so we divide this out. So 15.125 on the inside, 0.2 on the outside. When do we ever want to divide by decimals? We don't. So what can we do with 0.2?
Get rid of it.
We move it one place
Make it 2.
to the right. So what do we do on the inside? We go one place to the right.
Oh.
Yeah, right. So now this is actually not that difficult. It's just 151.25 divided by 2. Don't shout it out. Let everyone have a chance to get the answer. And let the people who don't want to work it out get it wrong. Okay? Don't be nice to people who are lazy.
No. Who are you talking to?
I don't know. Algebra kids?
Your imaginary friend? I feel like there was no one out there. You just talk. Oh my God.
Why would I talk to imaginary people? I don't even like talking to real people. All right, 2 into 151 is?
75.625.
So then 1250 divided by 2 is? Super.
How do you not?
But did you know that 0.65 is 5/8?
Yeah, I did.
Now you do.
No, that's how we said it. No, I didn't.
All right. And then actually, how many whole cakes can she actually make?
You have to, I don't know.
Can she make 76? No.
She can make 75 and a half.
She can only make
75.
75. Why would that round down?
Because it just does.
Wait,
You
how many?
can't make another one with the decimal parts.
Right.
You can make a special one.
You wouldn't say, well, I have 75 cakes decorated and I decorated part of the last one. Right? So even though,
Wait, but when you round up,
okay,
girls, focus.
so even though if this was just a number, yes, this would round up. But since this is actually something you would need, you have to round it down. It's the same thing with like the paint example. You can't paint a room with, like let's say you needed 75.6 gallons. You couldn't buy 75 gallons and finish the job, right? You would have to round it.
That's a huge, that's like 75
Okay.
paintings.
So the answer is 75. So rounding works a little bit differently depending on if it's an actual example. Yes, common sense, a big part of that.
So she decorated 75 mini cakes?
Yes.
Here, my Shh, easy bake up.
That doesn't make it taste bad.
That's what I was thinking.
Okay.
Ricky,
She doesn't use a big
All right.
quiet.
Number 2, small rectangle has a width of 3, so we can draw a small rectangle with a width of 3. Large rectangle has an area of 210 and a width of 15. If they're similar, what is the area of the small rectangle? Okay, so there's a couple ways you can mess this up. The first way is thinking you can make a proportion out of this.
Don't you do 15?
No. Well, you could, but that's sort of the long and unnecessary way.
Yeah, portion would be good.
No.
Okay,
We
you,
have two sides.
You can't do it.
all right. You can't use proportion for this because side lengths do not increase at the same rate as area. Okay? So that does not form a proportional relationship. So you could do what's her name said? You could divide this out, get the missing side, then make a proportion using the 3 side lengths, and then find the area of the smaller one. But that's a lot of steps. The other way we can do this is if we think of it as a scale factor problem. How do we get from 3 to 15? So we have a scale factor of 5, and then we think, how does the area change? Does the area change at a rate of 5? No. How does area change? Always.
By new times OG by scale factor.
Scale factor what? Squared. Why squared?
Because volume.
Because it's two-dimensional.
Because it's
Because it's area. Area's in 2 dimensions. Okay. So what is our scale factor squared?
25.
25. 5 squared is 25. Is 210, is that our new shape or our original?
OG.
That is a new shape.
It is.
So how can we get back to the original?
Use that divide by 5.
Not divide by 5.
Divide by 25.
Divide by 25.
25.
I feel like we keep going over the same type of problem and it just keeps going.
You know,
Yeah.
one ear and out the other.
I feel like if I gave you guys this problem and put 210 divided by 5 as an answer choice, we would still pick that all the time.
Yeah, I'll be honest, based on the start, I'm really this hard.
Really, this isn't that hard of a question.
I know.
Because really the only math you had to do here is 210 divided by 25,
8.7.
which is 8.4.
Yes, I was correct for one of those.
It's 2.8. The real answer is I just did what you told me to do the longest.
Okay, so over here you got, hey, you got 8 point,
No. I got 2.8.
No, here. no, but here you got,
Yeah, there.
Oh, 14.
okay, 14. And then you divide that by 5, you get,
No, you typed it by 3, and then you divided by 15.
oh right, because you did the
Oh, I didn't
proportion.
do it yet.
Yeah. Okay, so do 2.8 times 3, and what do you think you're going to get? 8.4. Yes. But thank you for telling me I was wrong. It's always nice to hear that.
You're wrong.
I'm right.
Hey, take it easy, guys. Take it relax.
Shut up.
I know.
Joey? Okay, but still, that doesn't make it appropriate, and I still have the mic turned on, and
Did it hear me?
it picks up a whole lot.
So it can hear me all the time.
Yes, John.
Times you've eaten dog.
Yep. Hey, that's right. It's true.
Wait, how is it true? Wait, if it's racing, how is it?
Okay, number 3. I can almost guarantee you get a problem like this. This shows up on like every test they'll ever give you. Ladder leaning against a building, so we can draw ourselves
It's a right triangle.
a building. And we lean a ladder up against it. Some people still have trouble with this. You ask them, like, put the ladder leaning against the building, and they say, okay. And that's their ladder.
What kind of ladder is that?
Looks like a swing set.
A ladder looks like
Oh,
this.
it's like a,
Looks like a swing set.
you know,
Dang, that does.
no,
So
the,
not to
out
slide.
of,
Looks like a slide.
you know, the,
So why is the leg broken and it's sticking out this way?
hey, I'm not an artist.
You can obviously tell.
They erased it.
Because that's not the kind of ladder we're talking about.
Ladder's just.
If it's leaning, yes, Sergio, I thank you.
Okay, now the artist.
That's not helping me, okay?
You forgot the shade.
You forgot the shakeable ladder.
So the ladder against the building.
Yay.
Okay, Sergio, still not helping.
Oh, I get it.
I can tell the difference between all 4 of your voices. 5.
Don't you have to do the?
So yeah, we're getting there very slowly because we have to. Yes. So ladder 10 feet long. Bottom of the ladder to the building. It's a total of 6 feet.
You already have C.
Still not helping. Want to know how far up the building this is? So this does make a right triangle. Anytime we're missing sides on a right triangle, we can use formula a squared plus b squared.
A squared plus B squared.
Then we look. All we need to remember is which of our sides is C.
The one across
C is always
across the right angle.
across the right angle, which case is the ladder. So that's 10 squared. That is hypotenuse.
I get a minus.
Okay. So 6 can either be A or B. Let's call it A because why not? So we square both of our numbers. We get 36 and 100. Then you just need to remember, since we're solving for the short side, is that going to be bigger or smaller?
You're gonna subtract it.
It's going to get smaller, so we subtract 100 from 36, or 36 from 100.
64.
So we get
Yes, it is.
b squared is 64. But we don't care what b squared is. We want just b. So what do we have to do with that number?
Times it by. Divided by 2.
Ooh.
Oh, you have to square it. Divided by 2.
How do you get that though? You take the.
The formula.
Okay, stop saying divided by 2, because that makes me want to hit Joey with a chair. You need the square root, not. Okay, if you say squaring it, that's different.
No, he said square root the last.
What? 100 minus 36.
It's 8.
Okay. And the square root of 64 is 8. But again, please don't ever divide by 2. That doesn't work. Okay. So our answer is 8. We also could have figured that out if you remember when I kept telling you that 3, 4, 5 triangles were going to show up all the time. And 6, 8, and 10 is just 3, 4, 5 times 2. So if you saw 6 and 10, you should be like, oh, well, duh, it's 8. Yes, Marco.
So the building is the answer.
Yes, a building 8.
What's the answer?
Hey, Sergio. A building. Your paper's over here.
No,
You
it's
obviously
not.
squared it.
What are we doing?
What?
Where's your paper?
Ricky smashed out of my hand.
Liar, you do it.
Why was it?
Yes, you. How old were you?
14.
It
wasn't anybody. Paper picks itself up, put itself on the chair behind you, wasted our time. Blame the paper, right?
What?
I blame the weight.
Yeah, because we're trying to figure out how the paper.
I believe we're such a. It's Carl. Carlos. Carl.
Hello, fellow.
Rick, what do you think?
12 days. That's all we got.
Nah, for real.
I'd like to make the most of it. We can laugh at John after it's all passed, but until then, can we try to get like this is sort of serious? Remember, think back to all those benchmarks we did really poorly on? Yeah. Yeah. So with our 12 days, let's try to make the most of it.
Is it 50 copies now?
Yes, but 30 is not 50. I mean, not even
Close. Okay, so number 4.
Number 4.
Roll the cube 50 times. Shows the results on our chart. What are the experimental and theoretical probabilities? So we can just put in theoretical up top, experimental on the bottom. If you already did this and you didn't put them in that order, that's fine. Remember, theoretical is what we want to happen. So if we want an even number, how many outcomes on our cube are even numbers?
3.
3, because it can be a 2, a 4, or a 6. So that's 3 out of 6, which is 1/2. And since it wants that as a decimal, 1/2 would be 0.5. And then the experimental probability is how many times those results actually happened. So how many times did we roll an even number?
26.
26? How did we get that?
Because
You add it all together.
We add up.
Frequencies of those frequencies.
So we wanted a 2, a 4, or a 6. We add up the number of times we got a 2, plus the number of times we got a 4, plus the number of times we got a 6, which is 26. Okay. Not the.
That's the one.
It's not the even number of frequencies. It's the even numbers on the cube. Okay. So 26 out of 50. Here's one of the few times when simplifying the fraction doesn't actually make things better. Since we want it as a decimal, we think, what fraction can we get a decimal from really easily? Well, we're not going to get a half out of 26 over 50 because it's not a half. What about out of 100? Can we write this fraction as something over 100?
46. Oh, no. Yeah, 26. 52.
Is 52, because times 2 is.
52.
And now what's 52 hundredths as a decimal?
52.
Is literally 52 hundredths.
Wait, so why is it 52 and not 26?
Because we want to write it as a decimal.
So why don't you just keep just 20.26?
Because that doesn't. It only works if it's over 100 or over 10 or over 1,000. So what you could do is you could have simplified that. You could have said 13 over 25. And then to turn that into a decimal, you would have to divide. And what do you think that would give you?
0.52.
That would give you 0.52.
So the answer's 0.52.
So then do that. I'm not really I mean, you know how to turn a fraction into a decimal? This isn't something I'm teaching. I'm just showing you that if you can write a fraction over 100, it's written as a decimal already. If the denominator was 50. It doesn't always work. But when it does, it's pretty nice. Yes, 0.52. Last problem? Next problem?
Yes.
So this one?
No!
The next one? 6?
Number 5.
Number 5?
Doing, sir?
Day 5 was yesterday.
Oh my god!
Oh, question 5.
God.
You both said it.
Well, you want to do it on your own? Okay. Let's talk about number 4 some more. Did you? What? What'd you say?
Say final bell.
I said jingleberry.
Oh. Don't call me any kind of berry.
That makes it better.
Hello? Yes. I'm running out of kids in here, but okay. I got like 4 kids in ISS right now.
Oh, this
They probably did. All right, I'll send her down.
Good job.
Okay,
Get her
bye.
out of here.
Yeah. You.
Me?
Yes, you.
You got caught. You're gonna be troublemaker. Get out of class.
Oh, what did she get? What did she get in this car though?
So you want to do number 5?
Yes.
I'm not any type of berry, correct?
No, you're a cranberry.
You're a jingle berry.
What?
Those cranberries. That's like worse than when you said sesame seeds instead of sunflower seeds.
What is up with the new trend of sunflower
I
seeds?
know.
It's that,
I could care less if
it's
you're
that,
Just go. No, we don't.
what? We're trying to learn. Alright. So, sides of a square are doubled. The area of the square would be multiplied by
4.
Why 4?
Because he has 4 sides.
4 sides.
No.
What are doubled by 2?
Okay. So if the sides are doubled, that means we have a what? Scale factor of 2. Thank you.
But I thought you said every time like. Does that work with? Is that area or first?
Okay. So if the side lengths are doubled, that means scale factor is 2. So to figure out how area changes, does area change by the same factor as side lengths? No. Area is always. And I'm going to keep writing it.
Mu equals original times the square.
Not a whole lot of people get anything out of it, but I'm going to keep writing it. Area changes by a scale factor squared. Cody. So if our scale factor is 2, what is 2 squared? 4. So how is our area going to change?
Times 4.
Times 4.
Yes, that's what I said.
Means the battery's dying. So the area changes by a factor of 4.
That's what Joey said, and you were just like, no.
That's because you said because of the number of sides.
It is. Wow.
Oh, it's not.
Okay.
The scale factor squared is 4.
But what if the scale factor was 3? What would the area change by? Still 4?
6.
No. Not doubled.
It says in the question.
It changed by 9 because it's squared.
Okay, we're doing a different question. If it tripled, the area would change by 9.
9. I know I said that.
Because it's always scale factor squared.
Next question.
What have you done on your own? Stephanie's over here like, you haven't done enough work for me yet, Mr. Ellis.
Yeah.
Thank you for encouraging me. I'm going to pass this test. I don't know about you. But I will. And that's pretty
You
good.
were going to pass this test 35 years ago. So just take
How old is this?
You're lucky.
You're only 27.
I'm lucky because I passed.
You don't have to do the stupid test.
Bro, he had it back when it was taxed.
How do you think I got this job? You don't think I had to pass a
You
test?
paid yourself off.
You know what? It's not as hard.
Mr. Elk, you're secretly rich.
My
You
mom
paid
did
your
have
teachers.
to
Yeah. What? Okay. To teach middle school, you actually have to pass a test that it really tests your ability to do high school math too. So, and then I took the high school test, and that required the college math as well. So, please don't.
Qualified for high school
so-
and middle school
yes.
and college. Oh, Professor Ellis.
Professor. Why are you calling that?
If I had my master's, I could, but then I would miss out on the joy of.
Being called a Mary.
Yeah.
Professor Ellis.
All right.
I call him that after I
Perimeter of the base. All right, quiet. I have to do Stephanie's work for her. Otherwise, it won't get done. All right, perimeter of the base. What shape is this?
It's a triangle.
Okay, this is a. All right, I'm gonna say this real slow. This is a triangular prism. Okay. Now I'm gonna ask this next question. A bunch of you are gonna get it wrong, and I'm gonna shake my head. What shape is the base on a triangular prism? Is a triangle. Okay. The base is not the bottom.
Prisms always have two.
Okay. The key to knowing what shape the key to knowing what shape the base is, if you read the shape, if it's triangular prism, the base is a triangle. Okay. Then the base would be a rectangle. Okay. If
If it was a dangleberry prism,
You missed all the fun.
Turned it off.
Literally missed all the fun. Mr. Ross Lindsay missed all the fun.
there's no fun in here. Okay, so find the perimeter of that in inches. So 7.5 feet, how many inches is that?
12.
How would we get that? 7.5 times 12. All right, everyone needs to work that out so Stephanie will have the answer. Because she won't do it herself.
I already did it.
And what'd you get?
900.
Okay, good. Wait, wait, what? 900.
Yeah.
300.
Oh, 9.9.
900.
300.
How do you get 900?
Wait, where are you, dude? Who taught you guys math?
It's 300.
It's 90 because you have to move the decimal.
Yeah.
You forgot to move the
900.
decimal.
How do you get 900?
I got 900, but I needed to
Okay.
move the decimal.
I knew there was a 9 in there somewhere. So now, what kind of triangle is it?
Isosceles.
Obtuse. That's an angle.
Okay. None of those answers you've said so far have been right. All right. Please stop guessing because it's making me sad. What do these little lines represent? That all the sides are the same. So this is an equilateral triangle. So if one side is 90, what are the others?
30.
90.
Day 30.
90.
Hey, nobody got time for you.
Hi, Kaylin.
Okay.
You got time for your pancakes?
All right. Please don't talk to 8th graders. Don't talk to 8th graders.
Come on,
Do
Professor.
you know what grade this is?
What? I don't know. You must be one of Schaefer's kids, right? That's why I don't know you. I only know the opposite of the good kids.
Now you're a
And you're laughing like, ha ha ha. Wait. Oh.
Crusty
It's
berry.
270.
It is 270.
Your microphone's not even on.
See,
you guys are good kids. You can add 90 plus 90.
That's not what you said earlier.
Yes.
So proud. Or
I'm
90.
so sure.
So that's 270 inches. Since it's perimeter, is that inches squared?
No.
No, perimeter is just in one dimension.
I just showed them my own.
So the answer is two.
I know, right? Don't say it's a
Is that right? And how do you say
X's, common denominator.
Anytime you see the word sequence, your first thought should be, boy, I should really make a
Sequence, table chart.
table.
Number,
What's your first thing? I'll say line.
term.
No, what's the value?
I put term.
So anytime you see sequence, the first thing you should make is a table.
Ow.
Oh, I didn't know what you mean.
If it says first 4 terms,
1, 2, 3, 4, 5, 6, 7, 8, 9.
we just need 1, 2, 3, 4, because those are the first 4 numbers.
I don't know.
How can we find the value of those?
Plus 4.
We start with n equals 1, and anywhere we have 1 in our little expression, we're going to replace it with a 1. So we have 3 times 1 plus 4 times 1 plus 1. So all we've done is we've taken...
You guys ready to do this on your own? No. Then please stop playing around. Maddie, you too. That's like one of the most absurd things ever. I can be like, hey, Roland. And I'd be like, what? Like, he doesn't know that he's talking, and I'm calling on him because I need him to stop talking. Right? Why is that?
Have you seen Here Comes the Boom?
Oh, man, that's a funny movie.
Be quiet.
This does work out to 11. So what? So now we do the same thing. Yeah. So we take the same expression.
No, okay, 2 plus 1, that's tree. Plus 4.
No, times.
Yeah, because when a number's extra parentheses,
Okay, so it's 7. 7 times 2 is 14. 14 times
Wait, where did you get 7 from?
It's 22.
No, 3 times 4.
Yeah.
It's not 7. Where on?
Why is he always doing it? Shut up. 12. And then times 4.
Why is he going backwards?
Because I don't know how to do this.
You go forward.
Okay, shh. I don't remember letting him come up here, but he's already here, so.
That's what Chris Ralph.
I get it.
Hurry up.
Well, how am I supposed to do this? That's what I'm asking.
Let Mr. Ellis do it, you'll find out.
Yeah.
They go by 11.
It's just 14 No, it's 10. And
Wait, okay.
He's messing up the YouTube
You
viewers.
gotta sit down, Joey, because you're...
Is that the microphone?
Yes. Because that, it doesn't make you look bad, it makes me look bad, because I don't know what you're doing up here. 3 times 2 is 6. 3 times 4. 12. 6 plus 12. 18.
Oh, yeah, that's like the only thing that's in reverse.
Okay. That was adventurous.
Mr. Ellis, PEMDAS, write that on.
Yes, pandas.
John would have said that too.
Alright. So,
So I'm guessing it's just plus 8.
no. Okay. 4 times 4 is
16.
3 times 3. 9 plus 16.
25.
25. And one last one in case you haven't seen the pattern.
It'd be 32.
So 3 times 4.
Wow, that color's awesome. It's like gold.
That's like a juice color.
It's orange.
5 times 4.
It's 32.
It needs to be
82. 82. Come on. I can read.
Okay. This one? What's 3 times 4? What's 4 plus 1 is? 4 plus what's 5 times 4?
You guys.
All right.
Yeah.
Go bring
Johnson back in.
Stephanie, why are we doing your work if you're not even listening?
Because she's an
All right. Wow. Ups makes 120 million deliveries the week of Christmas. How many did they deliver per hour? So if they went 8 hours a day for 5 days, how many hours did they work?
35.
40.
40. So it's 120 million in 40 hours.
40 hours. You just divide it.
So we divide 120 by 40 and we get
30. 30.
we get 30.
30 million.
No, it's not 30.
Yeah, it is.
It's not. 120 divided by 40 is 3.
That's what we were just gonna. Oh, 3, not 30.
I just said that.
Okay, super, and I wrote it. So, no. So it's 3 million per hour, but how does it want us to write that answer? Okay. So, so we need to put in our zeros here.
0, 0, comma, 0, 0.
Okay. If you had bank accounts like mine, you would know this pretty well. Or Ricky.
Ricky has 14 trillion and 7 bank accounts.
All right. So now we need to move our decimal to make a number between 1 and 10.
After the 3.
After the tree.
After the tree. So it's going to be
6.
3 or 3.0 times 10 because we moved it 6 times. If you put 3.0, that's fine. It's really the same thing. Okay. You writing this down?
Yeah.
When? That's not on the paper, Roland. Not that I don't trust your head, but... On delay? You're the one asking me what the answer to number 7 was. After we were done with it. Uh-huh.
No.
Does the point negative 8 by 8 lie on the line y equals negative x and what? I'm gonna put yes.
I'm putting no. I'm gonna.
1, 2, 3. Negative. No, it doesn't.
So we want to know, does y equal negative x? So what is our y coordinate? 8. They want to know, does that equal the opposite of x? So what is our x coordinate?
-8.
So what is the opposite of -8?
+8.
So then does 8 equal 8?
Yeah.
Yes, so this part is true. Okay, now the second part, is that point in quadrant 2? Well, if we remember our quadrants here, we have 1.
3, 4.
Okay, what's true about quadrant 1?
They're all positive.
Positive, positive. How about quadrant 2?
Positive, negative.
What? The x values are negative. Quadrant 3?
Negative, negative, and then negative, positive.
Hey, look, there's
Just
me.
John.
John, I knew you were going there. Stop.
How about -8, 8? What's true about that? X is negative. So what quadrant would that point fit in? 2. So does it lie on that line in that quadrant? The answer is
Oh, that's the answer. Oh. That's the first one.
It do.
No, that does wrong. It's about obviously.
Obviously.
It do. Yeah.
It do.
Oh, yeah, that ghetto grammar.
okay. Make sure you put the correct answer.
Box everything and see what happens.
We just went over it.
Alright.
Oh, so it's not hilarious.
Guys, we only have a couple of minutes to work.
Oh, you boxed it. Oh, that's why I did it. Oh, man, it does.
All right.
I did too.
Okay, Casper earned $30.
Jasper.
I know it's Jasper, I can read.
Well, one problem for homework's not that bad, right?
Yeah, we can just Google it.
Okay.
Siri's my best friend.
Because clearly just sitting there and being quiet for 2 minutes would be more work.
No. Mr. Ellis, we can be quiet for 2 minutes.
Can you?
Yes.
Ricky! Ricky, pull up your dog.
Go.
I can't.
Yes, you can.
Yes, Obama said it. Yes, you can.
Yeah. He said move forward.
Exactly, yes,
That's what he said.
Just keep going on.
All right, so then keep going on. Answer number 10. Oh, you can't, but I can.
He didn't spend $10.
We look up Obama speaks
Okay.
backwards and he's saying thank you.
I know.
How much?
It is not asking about any sort of dollar amount. It's asking for what fraction he did not spend. So do you need that $30 at all?
No.
No.
I know that.
You wish your hair was as soft and luxurious as mine.
No, you're just like gross up.
Don't need a hair
Look right here like you gross up.
Yeah.
Mine grows. Go on your weave now.
I wish all of you guys would grow up.
Man, I gotta go sharp.
I don't get it.
Don't forget tutoring from 4 to 6. If you don't show up, you're missing out on.
Wait, what do you mean 4 to 6?
Go home, Roland.
Does our video go on YouTube?
No.